Everything is possible. We make it work.
Hi ladies and gentlemen, my name is Keith Bryant and I'm here to explain SmartLoop, a brand new, unique yield improvement technology. The aim of this technology is to give more information, more data to people who are running production lines. Historically, I have a lot of years in X-ray and AOI industry. I've always been bothered by the fact that inline X-ray produces false calls. All of the people who use inline X-ray accept the fact that there is an amount of information that they don't know about. They don't know, is it good, is it bad? They have a percentage of everything that they have, which possibly it's good, possibly it's bad. Reality, they don't know. You cannot have a quality management system without knowing exactly what is happening with your product. How many good ones you have, how many bad ones you have, how many to rework. And with inline X-ray, you don't get this information. You just get a gray box called false calls, a box called escapes, and a box called definite fails. And there's a big gray area within that. And it's very difficult to run a process, well, it's impossible to run a quality management system with that level of data. The implementation, the arrival of 3D inline AOI gives a large advantage to this kind of customer. You have faster process, you have more accurate information, and you know a lot more detail than you do when you work with inline X-ray. But unfortunately with 3D inline AOI, you still have an issue with lack of complete data, because its definition is optical inspection. It can only measure, it can only report on what it can see. So bottom terminated components like BGAs and QFNs cause it some issues. They can measure flatness, they can measure coplanarity, they can measure warp. What they cannot tell you is whether the joints underneath are any good or not. And this has always been a hurdle to the adoption of this kind of technology from the people who demand 100% inspection of their products. So SmartLoop takes data from the 3D inline AOI system, puts it into the X-ray system, so only suspect parts are checked. All of that detail, including SPI information, is then displayed on a management information screen, so a technician can make a value judgment on the quality of his product and the quality of his process. So now he can make continuous process improvements by controlling the limits of his SPI machine and his 3D inline AOI machine, using his at-line X-ray as a verification for real-time product inspection. This is a unique system. I have to thank both of the initial partners in this technology, working with Mirtec and working with Exelon. We have developed this technology with them within a 3-month window to launch. That's a tremendous achievement for the whole of the industry and a testament to how seriously they think the advantages in this technology will be. So I'd like to hand over now to Philip. We have 2 machines and a management information system behind me, and we're going to actually walk you through how the technology works, and you can see its advantages at every step. So, Philip, over to you.
Okay, so here we have our Mirtec MV7 Omni 2D 3D AOI. What we're going to do is inspect the board and see what sort of defects we get. Okay, just skip the barcode for the moment. Okay, at the moment the machine is scanning through. inspecting all the boards. Okay, so we have faders on the board. Now what we see here is this component has a height error. In the top right hand corner, we've detected that the height is above our maximum. And obviously we don't know why. So easiest way to find out is to pass it on to our X-ray machine. Also, we have a QFP here, which has some bridging, and also it has some issues with some bridging on the top here as well. Now again, everything for us, it looks fairly normal, but X-ray should be able to tell us more.
So I just received the board from the AOI machine. In order to identify the correct board, we could now scan the board for the barcode and identify it. Once the board is properly identified, we put it in, close the door. In the meantime, we have received the coordinates so that we know the position of the two parts that we are interested in. So we have the board in the X-ray machine. I will start the SmartLoop extension. The parts that we're interested in are positioned in the live view of the X-ray image. We also received data from the AOI machine, like which lane was involved, which part number is involved, and the position of the part. So now we can go ahead and basically inspect the part and find out what the real problem is. And as we can see in the image, there's a reason why we had a height error, actually because there's 1, 2, 3 chips buried under the BGA. And that is the reason actually why the AOI machine detected a height error. We can also go to the next position. We also received the data for the next position, the next part, that is fault. Zoom out a bit, and here we go. So the system detected that there's an error on the leads, the AOI system. We can see that too, but we can also see the reason why there was a problem with that part. Because there's another chip buried under the J lead. Now we can say, okay, the inspection result of this part is bad. We press not OK. And then we hand over the data, the image and the inspection result to the master inspection screen.
Okay, so we're continuing through the process. The Mirtec 3D inline AOI system has picked up a problem with a height error. That is being transferred to the Exelon machine, which has now done its analysis, and now we come to the management system. So what we do is we click on the board, search for the boards. Okay, that. Here we have the X-ray data. Here we have the 3D data. And in a production line here we would have the BGA data, the pad data from the screen printer. Obviously this is at a trade show. We don't have a screen printer in position, so we've just taken it from our other booth where we do have an SPI machine, and this is giving you the simulation. So the data in real time now is available to the customer. He can see that his 3D machine has done the job it's meant to do. It's highlighted that there's a height error and the board has been failed. It's been sent to X-ray to determine what caused that height error. What we can see, as Matthias showed a few seconds ago, are the images with the chips underneath here, the BGA. So we've moved from catching the fault to knowing what created it, what caused it, and now With that information, the customer is able to look at his process. It might be a situation where you think, well, it was a dropped chip, it's a freak, it's not going to happen all the time. But nothing happens for nothing. Those chips have been dropped. Was it because the feeder is not set to the right pitch? Is it because the nozzles are getting blocked? There is a cause, and now we've given the customer the information to look at that and be able to analyze it and correct it before a little problem becomes a very big issue. This is the step from statistical process control, where historically you sit a week later, whatever it might be, analyze what went wrong on a certain day. Instead now we have dynamic process control, where in real time the data is sent to the customer can make his corrective action, and production levels, utilization of the line all increase. This is the way forward. AOI machines were designed to catch faults. Now they are evolving. Now we are helping our customers stop making faults.
Well, ladies and gentlemen, there you have it. In essence, that is SmartLoop, the ultimate yield improvement process. It is intelligent feedback. It gives operators, technicians, engineers, managers full data, complete sets of information on any failures, any suspect parts that they have on their boards. And now the industry has total process management capability, which it didn't have before. So SmartLoop is empowering companies who are embracing the technology to continually improve their yields, reduce their costs, become more competitive and stronger for the future.